Hello everyone, hope you are all doing well. In this video, I am going to explain this problem from Geeks for Geeks. Its name is kth smallest element. So let's get started. It is saying given an array ARR and an integer k, where k is smaller than size of array. The task is to find the kth smallest element in the given array. It is given that all array elements are distinct. In this problem, all array elements are distinct, but there can be a case when duplicates element can be present in the array, but that will be that will become another problem. So we will focus on this type of problem when all array elements are distinct and we have to find kth smallest element. What do we mean by this kth smallest? It means that if I say k is equal to 1, then I am talking about the smallest element of the array. If I say k is equals to 2, then I am I am talking about the element just larger than the first smallest. Now let us take an example to understand it in a better way. 7, 10, 4, 3, 20, 15. Suppose this is the array in which we have to find k is the smallest element and value of k is given as 3. First approach we can consider here to sort it. When we will sort it, it will become 3, the smallest will come in the front, then 4, then 7, then 10, then 15, and the largest of them all 20 will come at the end. Now after sorting, I am going to return, if the array name is ARR, I am going to return ARR of k minus 1. This k is which is given in the problem. Here as k is 3, then I have to return the element that is present as 3 minus 1 2th index, 0, first, second, and we know that this is smallest, this is second smallest, and this is the required element, third smallest. It will be returned when I do ARR of k minus 1. This is one approach, and we can solve it through another approach. And in this approach, we are using the partition function, modified partition function of quicksort algorithm. I hope you must have all implemented the quicksort algorithm. In that quicksort algorithm, a function is used, that is partition. And what this partition function do? It select any element from this given array and put it at its right position in the final array by placing all the elements smaller than this element, and here I have chosen this randomly 7, and this partition function will place all the elements smaller than 7 before it and all the elements larger than 7 after it. So we will use this concept to find the kth smallest element. Now if I select a pivot element here, if I select the first element as pivot element, I'm writing here, and I'm going to write all the elements smaller than 7 before it and all the elements larger than 7 after it. Elements smaller than 7 are 4 and 3. I'm going to write in order in which they are present in the given array, and as the elements larger than 7 are 10, 20, 15. 10, 20, 15. If k's value is 3, suppose k's value is 3, then we know that these elements are smaller than this element and these elements are larger than this element. when k is 3 and size of this, suppose this is our left subarray, this is our right subarray, and when k is 3 and size of left array is k minus 1, that is 2. Yes, it is equal, k is given as 3 and size of is 2, so k minus 1 is equals to 2. Then the pivot element will be our answer, because we know that two elements are present before it that are smaller than this element, then this element must be third smallest element in this array. And there can be another case when k is given as 2. When k is given as 2, then we know that its length is 2. The length of left subarray is, that is 2, is larger than value of k minus 1, in this case when k is 2. When the length of left subarray is larger than value of k minus 1, then we know that the required kth smallest element must be present in this part, in this left subarray, because we know that element 7 and two elements are smaller than the 7, then these two elements must be smaller than the 7 and all these remaining elements, because these elements are greater than 7. So these are only two smallest element in this whole array. And if I want to find second smallest element, then I will find it here only. So I am going to recursively make a recursive call on this left subarray with value of k as 2. There can be another case when k is given as 4. In this case, length is 2 and k minus 1 is 3 and length is smaller than the value of k minus 1. In that case, we know that three elements are present here which are smaller than these other elements present in the right subarray, and I want fourth smallest element, then that must be present in this right part. So I will make a recursive call on the right part, and but I will now change the value of k. Why? Because I have to remove these, I am going to remove these three elements, because I know that I am not going to search here, because I know that there is no chance of present, no chance that the fourth smallest element is present here, because there is only three smallest element are present, they are smaller than all these elements. As I am only considering this part, so I will remove these size of this element, left size of left array plus 1, left array plus 1 from the value of k. I will make recursive call on k minus length of left subarray minus 1, and this minus 1 is done for this pivot element, because we will exclude this also. Now let me try to code this approach. I'm not going to solve with that sorting approach, I'm going to solve this approach, partition approach. I'm going to call a function which I will make, let's name it quick select. This is the modified version of partition function of quick sort algorithm, quick select, and it will take array and value of k, and whatever this return, I will return that value from this kth smallest function. Now let's complete this function quick select, where I will add self def quick select self arr and k. Now, as this is going to be a recursive function, so first I will put a base case. What will be our base case? Base case will be if length of this list arr is 1, then the only remaining element will be the required element. Here I am going to return arr 0, and after that I am going to make a pivot variable, in which I am going to store the first element of the array. Now let's create left subarray, x for x in arr. I will exclude the first element as I have taken it as pivot, and I will put condition here if that element is less than pivot element. In right subarray I will do the same thing, x for x in arr 1, if x is greater than equal to pivot element. Now here I am checking the three cases of length of left subarray. If length of left is equals to k minus 1, then we know that the pivot element is the required kth smallest element. Then I'm going to return it, return pivot. In other case, if length of this left subarray is smaller than k minus 1, so it is the case when I will find my kth smallest element in right part. So I'm going to return and make function call, recursive function call quick select on the right part. Here I'm going to pass right, and I will change the value of k as k minus length of left minus 1, and in other case I'm going to return, in this case the length of left part is greater than k minus 1. In this case our required kth smallest element will be in the left part. So I'm going to make recursive call quick select with left and same value of k, and I will put self here and here. Let's try to run it. Yes, it is showing that all the test cases are passed successfully. Hope you liked the video. Thank you.